Professionals navigate intense, high-stakes environments daily. To decompress after absorbing that pressure, many rely on a familiar social lubricant at the end of the day. The modern workday generates a relentless volume of sensory and cognitive data. When cognitive load peaks, the desire to force a momentary pause becomes acute. Elite performance relies on what we call the composed state, an absolute baseline of calm and executive control, where you direct your focus rather than simply reacting to external stimuli. Using ethanol to forcibly relax introduces a fundamental friction into the nervous system. This chemical intervention to induce calm actually drives a sustained increase in baseline anxiety over time. To master cognitive performance, we must look at the biology and dismantle the ingrained habits surrounding stress relief drinking. Older observational studies once suggested moderate consumption offered cardiovascular benefits. Modern, large-scale genomic analyses have disproven those models, linking consistent intake to hypertension and mitochondrial stress in the heart muscle. This chart displays the systemic toxicity of ethanol across 4 major biological systems. In the neurological system, even moderate consumption correlates with a measurable reduction in both gray and white matter volume, directly impairing executive function. At the cellular level, the World Health Organization classifies alcohol as a Group 1 carcinogen. As the body metabolizes ethanol, it produces acetaldehyde, a chemical that damages DNA and prevents cells from executing standard repairs. Metabolically, it drives hepatic lipid accumulation, or fatty liver, which disrupts how the body processes glucose and triggers systemic insulin resistance. And in the endocrine system, alcohol consumption forces immediate and sustained spikes in cortisol, locking the body into a state of chronic stress. These failures do not occur in isolation. They compound to create a highly neurotoxic environment across the entire organism. It is biologically impossible to maintain composed emotional regulation when the body's foundational systems are actively degrading. To understand why alcohol destroys emotional regulation, we have to examine neurochemical homeostasis, the strict equilibrium the brain maintains to function normally. This diagram shows the 2 primary neurotransmitters responsible for that balance. GABA is the primary inhibitory neurotransmitter, applying the biological brakes to calm nerve activity. Glutamate is the primary excitatory neurotransmitter, functioning as the gas pedal to keep the brain active. When an ethanol molecule crosses the blood-brain barrier, it artificially mimics GABA. This forces the brain into an unnaturally deep state of sedation. You interpret this physical heaviness as relaxation. The central nervous system, however, registers this sudden drop in electrical activity as a life-threatening system failure. The brain perceives this chemical sedation as a biological crisis requiring immediate and aggressive countermeasures to keep your internal organs functioning. To prevent the central nervous system from shutting down entirely, the brain initiates a defensive protocol. It purposefully reduces its own natural GABA production and floods the system with glutamate. The brain is essentially flooring the gas pedal to overcome the artificial brakes applied by alcohol. Over the next several hours, the liver metabolizes the ethanol and clears it from the bloodstream. The alcohol vanishes, but the compensatory chemicals remain. This hyperexcitatory state is called the homeostatic rebound. With the artificial brakes gone and glutamate still flooding the receptors, the nervous system hyperfires. This manifests as racing thoughts, an elevated heart rate, and a profound sense of dread. The phenomenon of hangxiety is the predictable biological result of unbraked excitatory neurotransmitters colliding with a system that has lost its natural ability to find calm. When this cycle repeats, it triggers a biological process called allostasis, achieving stability through permanent systemic change. This graph models a healthy baseline of daily stress. The nervous system encounters stimuli, reacts, and returns to a resting state. Professionals managing high-stakes workloads expend significant metabolic energy just to maintain this calm state. Repeated cycles of chemical sedation and homeostatic rebound force the brain to adapt by moving its permanent set point. This upward shift represents the accumulation of allostatic load. The brain physically alters its receptor density. It abandons its original capacity for calm, assuming this new high-stress state is the required normal. When perfectly sober, The individual now experiences a constant, agitated buzz of background anxiety. You drink to feel normal, unaware that the drink is the exact mechanism that moved the physiological goalposts of normalcy in the first place. This neurological imbalance aggressively signals the endocrine system, specifically targeting the hypothalamic, pituitary, adrenal, or HPA axis. This flowchart illustrates how chronic ethanol consumption locks the HPA axis into a continuous loop, triggering persistent releases of cortisol. Cortisol keeps the body's stress response elevated even during periods of complete sobriety. Stuck in a biochemical emergency, emotional recovery is physically impossible. Compounding this stress is the suppression of REM sleep. Alcohol acts purely as a sedative, not a sleep aid, leading to frequent awakenings as it metabolizes throughout the night. This fragmented sleep restricts the brain's glymphatic system from clearing metabolic waste, accelerating cognitive aging. Trapping the body in a chemically forced state of endocrine emergency guarantees a slow, completely invisible collapse of executive function. High-stakes professional success relies heavily on metacognition, the ability to monitor and regulate your own thought processes. Metacognition depends entirely on the structural integrity and quiet focus of the prefrontal cortex. By inducing structural atrophy and locking the nervous system in a state of chemical agitation, alcohol effectively blunts this precise brain region. The chemical sedation provided by ethanol eventually fades to reveal a nervous system that has been biologically rewired to be less resilient than it was before the first sip. Escaping this trap requires allowing the brain ample time to repair its receptor density and return to its unadulterated baseline. True mastery of your internal environment, achieving the composed state, requires a brain operating exactly as designed, entirely free from the chemical disruptions of ethanol.